MICO designs, manufactures, and sells hydraulic components and systems for heavy-duty off-road vehicles and equipment. We have been providing our customers with quality hydraulic braking technology and services for over 50 years. Welcome to our series of MICO product training presentations. This presentation will cover our Caliper Disc Brake product line. Let's first discuss vehicle foundation brakes and their function. The function of a vehicle's foundation brakes is to decelerate and stop and/or hold the vehicle stationary. Braking can be categorized as static or dynamic. Static braking is already stopped or parked, and dynamic braking is decelerating or stopping. MICO has caliper disc brake designs for dynamic as well as static braking. Normally, an automobile will use either rotor or caliper brakes at each of the four wheels, or rotor and caliper brakes at the front wheels and drum and shoe brakes at the rear wheels. In automobile brake applications, the front brakes do the majority of the work. On the most basic level, all hydraulic brake systems share the same principle: muscle strength amplified by leverage. Your foot presses on the brake pedal, which displaces fluid from the master cylinder and causes pressure to increase throughout the brake circuit. Brake shoes will contact the rotating brake drum on drum brakes when pressure in the brake circuit causes hydraulic force in the wheel cylinder to overcome the mechanical force of the return spring. The greater the pressure in the brake circuit, the harder the brake shoes will be forced against the rotating brake drum. The stationary brake shoes rubbing against the rotating brake drum causes friction, which in turn creates heat. As the rotational speed of a brake drum decreases, heat created by friction increases, thus the principle conservation of energy. That is, energy can neither be created nor destroyed. It can only be changed from one form to another. When designing brakes, it is very important that the brake components are capable of safely absorbing heat and dissipating it without causing brake component damage or brake system failure. There are a number of drawbacks to drum brakes. They are more sensitive to changes in the coefficient of friction in the brake shoes. Drum brakes are prone to brake fade. This is where braking torque builds to a point and then seems to drop off, requiring increased pedal force. Because drum brakes are enclosed, they do not dissipate heat easily. Also, as the linings wear, there is no exit for the lining dust or other contaminants, so they build up inside the drum. Drum brakes are self-energizing and often duo-servo. This means the shoes are not anchored at the bottom, allowing the leading shoe to rotate slightly when applied. This pushes the trailing shoe tightly against the drum, which can make drum brakes lock up during hard stops. Weight transfer adds to the problem of over-rear braking, so even vehicles with disc brakes at all four wheels need some means of keeping the rear brakes within bounds, and that is why proportioning valves were invented. Proportioning valves limit pressure to the rear brakes after a certain pressure has been reached. After this pressure is reached, force to the rear brake lines is allowed to rise at a portion of the maximum available. The valve does absolutely nothing during normal or low-pressure stops. A variation of this valve is the load-sensing proportioning valve. It is found on some four-wheel drive sport utility vehicles and various small trucks. The distance between the body and the axle changes as the rear springs compress under a load. This distance is used to adjust rear stopping power to match the weight on the rear wheels and prevent lockup. The anti-lock brake valve was also designed to control wheel lockup during braking. Basically, an anti-lock brake system monitors the speed of each wheel. When one slows more than the others, hydraulic pressure to that wheel is released and reapplied up to 15 times per second to prevent lockup. There are two types of caliper disc brakes: sliding or floating and fixed. The most common disc brake used on modern automobiles is the single-piston sliding caliper disc brake. With a sliding or floating caliper, brake pressure on the single piston forces the lining against the rotor. While the caliper housing is pulled toward the rotor, the opposite lining, which is mounted stationary in the caliper housing, also contacts the rotor. A fixed caliper has a piston on each side of the rotor, which force the linings against the rotor simultaneously when brake pressure is applied. The sliding or floating caliper and the fixed caliper can also have multiple pistons. Multiple piston calipers often provide greater torque due to the larger surface area of the pistons. Normally, there is no spring to pull the brake pads away from the rotor. Therefore, the pads stay in slight contact with the rotor. The rubber piston seal and any wobble in the rotor disc do actually push the pads a small distance from the rotor. This close contact is important because the caliper brake piston diameter is much larger than the master cylinder piston. If the caliper pistons were to retract into their cylinders, you might have to pump the brake pedal several times to get enough fluid into the brake cylinder to engage the brakes. Most automotive rotor discs are a ventilated cast iron type with the friction surfaces ground or turned smooth. Ventilated rotors are typically 1 inch to 1 1/4 inches thick. The caliper disc brakes that MICO manufactures are designed to be used with a solid rotor disc that is 1/2 inch thick. MICO recommends using a low to medium carbon steel for rotor discs. 10/18 grade steel is a common grade used. When high carbon steels are used for rotor discs, heat causes the disc to develop stress cracks. When too low of a carbon steel is used, it may not have the structural strength necessary for certain applications. MICO recommends that disc friction surfaces be flat within 5/1000ths of an inch and parallel within 2/1000ths of an inch. MICO also recommends that the friction surfaces be Blanchard ground from 54 to 72 roughness average with a visible crosshatch pattern. Roughness average is the arithmetical mean roughness of a surface. It is expressed in units of height, typically in millionths of an inch. The rotor disc should not have an overly smooth finish because the disc is used to wear in new linings. This is called burnishing. A well-burnished disc will look like it has a mirror finish. This indicates that the lining and disc are mating well and that friction levels are quite high. A new unburnished lining and disc may have friction levels as low as 50% of a fully burnished lining and disc. Determining the basic brake torque that a caliper brake is capable of providing can be calculated using a formula where disc clamping force times the number of rubbing surfaces times the mean disc radius times lining coefficient of friction equals brake torque. F sub C is the disc clamping force, the force on lining. This force can be hydraulic, spring, or mechanical. N is the number of rubbing surfaces, normally 2 since there are normally 2 linings. R sub M is the mean disc radius, the distance from center of the disc rotor to center of the lining area that contacts the rotor. U is the lining coefficient of friction. The definition of coefficient of friction is a measurement of the relative friction characteristics of various materials. An example of coefficient of friction would be a block setting on a plate of flat steel. Coefficient of friction is the actual force it takes to move the block divided by the force of the block on the plate. Coefficient of friction can vary greatly when you compare sliding something across the ice as compared to sliding it across dry pavement. The ease of being able to do this is indicated in a numerical value. This graph indicates coefficient of friction from 0.1 to 0.6. It shows the results of 2 different brake linings tested at MICO for coefficient of friction characteristics. One lining was from PM Automotive and the other from Carlisle. The blue lines represent pre-burnished linings and the red lines represent post-burnished linings. The post-burnished linings have a much greater coefficient of friction. Normally the ratio is about 2 to 1. If the lining or rotor becomes wet or oily, the coefficient of friction is significantly reduced. Any specifications and values for caliper disc brakes in MICO literature is based on dry linings at burnished condition. The materials used in the linings tested on this graph are signified as organic. Lining manufacturers do not disclose their lining formulas. They are mainly different types of ground-up organic material that are mixed together with some type of binder or resin and held together by a heat process. These types of linings are capable of operating to temperatures of about 500 degrees Fahrenheit. Organic linings can vary in how hard or soft they are. Usually softer material has a higher coefficient of friction, but they will also wear faster and won't have as much heat capacity. A harder material will normally have a lower friction, but will last a lot longer. All MICO linings are non-asbestos and lead-free. Something to consider when using a MICO Caliper disc brake is where it will be located. Many MICO Caliper disc brake applications are used on the driveline as parking brakes or emergency brakes. When caliper brakes are used on the driveline or the axle, gear reduction needs to be brought into consideration when determining the required brake torque. Brake torque is divided by the ratio of gear reduction to get the actual required brake torque. Gear reduction is conducted through planetary gears, differential gears, or both, depending where the brake is located on the vehicle. When the brake is located on the driveline, both the differential gears and planetary gears can affect braking. When the brake is located on the axle, the planetary gears can affect braking. And when the brake is located at the wheel, braking is not affected by gear reduction. The wheel loader application shows MICO 520 series brakes at the four wheels and a MICO 530 series brake at the driveline. However, be aware that internal multiple disc brakes built right into the axle are fast replacing this type of application. The advantage is that it eliminates the contamination and they normally have a longer wear life. There are three series of caliper brakes available from MICO: the 515 series, the 520 series, and the 530 series. 515 series brakes are available as mechanical apply, spring apply hydraulic release, and hydraulic apply. Although this series of caliper brakes is normally used for static braking applications, they could be used for limited dynamic braking applications also. 520 series brakes are all hydraulic apply. The 520 series brakes are available with different types of housings depending on the application. 520 series brakes are physically larger than the 515 series. Of all the MICO Caliper disc brakes, the 520 series is the most commonly used in dynamic braking. All 530 series brakes shown are spring apply hydraulic release. The main difference between 530 series brakes is the output torque provided by the spring pack. These brakes are normally used for parking or static braking applications. MICO has been manufacturing the 515 series floating caliper brakes since 1973. This brake is quite compact in size and can be used in a variety of applications when a disc is incorporated in the vehicle or machine. Some typical applications include paper mill rollers, forklifts, man lifts, winches, sawmills, and marine service. The 515 series spring apply hydraulic release brake shown here is in the fully retracted or released position. Hydraulic fluid entering the pressure port causes hydraulic pressure to build in the internal cavity, which forces the piston to move away from the rotor disc and compress the Belleville springs. This action allows the clamping force of the linings to release. As hydraulic pressure continues to be introduced into the pressure port, the piston will move farther away from the rotor disc until the linings are fully retracted. As long as this hydraulic pressure is present, the linings are maintained at full retraction. When hydraulic pressure is removed from the brake, the Belleville springs force the piston toward the rotor disc until full clamping force of the brake is established. This brake does not automatically adjust to compensate for lining wear. Regularly scheduled manual adjustment is necessary. The 515 series hydraulic apply brake shown here is in the static position. Hydraulic fluid enters the brake through the inlet port and causes pressure to build in the internal cavity. This pressure causes the piston and linings to contact the rotor disc and provide clamping force. When hydraulic pressure is removed from the cavity, fluid exits the brake and the piston returns to its original position and provides disc running clearance. A clip spring holds the linings away from the rotor disc to prevent rattling while the brake is in the static position. The 515 series mechanical apply brake shown here is in the retracted position. This brake uses 2 cam plates and 3 balls to convert rotary motion to lateral motion. When the brake is fully retracted, the cam pockets are aligned and the balls are in the deepest portion of the pockets. When the bidirectional lever is rotated, the 3 balls climb the cam plate ramps and force the piston to move toward the rotor disc, causing the linings to provide clamping force. When the lever is released, Belleville springs cause the brake to return and maintain a retracted position. This brake does not provide for automatic lining adjustment to compensate for lining wear. In addition to the fixed mechanical advantage provided by the cam plates, the lever also provides mechanical advantage. The maximum allowable clamping force of this brake is attained when 330 pounds lever pull is applied at the outside hole of the lever or 420 pounds to the inside hole. MICO has been manufacturing the 520 series caliper disc brakes since 1966. All 520 series brakes are mounted stationary or fixed over a rotor at the wheel, driveline, shaft, or hub. Several models are available to accommodate various mounting and torque requirements, with the operation of each being the same. These medium-sized brakes are used in many applications and are used extensively in mining, forestry, farming, and construction. This 520 series brake is a split caliper design and can be used with a variety of disc thicknesses by changing the spacer thickness between the two caliper halves. The brake is provided with a crossover tube and a standard spacer for a half-inch thick disc rotor. The spacer can also be used as a torque member. A torque member provides opposition to the forces generated by the brake. The 520 series caliper brake shown here is in the static position. The operations of both halves of this brake are the same. An external crossover tube provides both halves of the brake equal hydraulic pressure, so they actuate simultaneously. Hydraulic fluid enters the brake through the inlet port, which is located on the opposite side of the brake from the crossover tube. As hydraulic force builds in the cavities, the pistons and linings move toward the rotor disc, causing the seal O-rings to deflect. As pressure increases, the linings contact the rotor disc and provide clamping force. When hydraulic inlet pressure is removed from the brake, fluid exits the brake through the inlet port and equalizes in both brake halves. The seal O-rings return to their original shape, which causes the pistons to return to their original position and provide disc running clearance. The housing of this 520 series brake is made of aluminum and is lightweight for its size. It is designed for use with a disc rotor a half-inch thick and a diameter of 10 to 24 inches. This brake does not use a spacer between the two halves, so it is mounted flush with the torque member. It is shown in the static position. Operation of this brake is the same as the 520 brake on the previous slide. However, this brake uses internal porting to communicate equal fluid pressure to both sides of the caliper. This 520 series brake is used in applications where the customer provides the spacer between the caliper halves. The torque member in this case can serve as the spacer. The design of this brake allows for use with a disc diameter of 9 inches to unlimited, or a straight rail to provide full lining to the surface contact. The customer must plumb hydraulics to both sides of this brake. It is shown in the static position and operates the same as the 520 brakes in the previous slides. This 520 series brake is a one-piece caliper with internal porting to provide hydraulic pressure to both pistons. It mounts flush with the torque member and is designed for use with a rotor disc thickness of 1/2 inch and a diameter ranging from 9 to 36 inches. The brake is shown in the static position and operates the same as the other 520 series brakes. MICO has been manufacturing the 530 series caliper disc brakes since 1970. The 530 series brakes are sliding or floating type brakes that are mounted over a rotor at the wheel, driveline, shaft, or hub. Several models are available to accommodate various mounting and torque requirements. These medium-sized brakes are used in many applications in the mining, forestry, farming, and construction industries. The 530 series disc brake shown here is in the released position. Hydraulic pressure is forcing the piston to compress the Belleville springs and provide disc running clearance. Retraction of the linings is maintained as long as fluid pressure is present. When hydraulic pressure is removed, spring force causes the pistons to move the linings in contact with the rotor disc. This brake is designed for use with a rotor disc thickness of 5/16 to a 1/2 inch and a disc diameter of 9 inches to unlimited. Properly adjusted, this brake provides maximum brake torque when no hydraulic pressure is present. It is not self-adjusting, so regularly scheduled manual adjustment is required to compensate for lining wear. The 530 series disc brake shown here is in the release position. It is physically larger than the 530 brake on the previous slide and provides higher brake torque. The operation of this brake is the same as the 530 brake on the previous slide, except this brake does not require manual adjustment during the useful life of the linings. However, as linings wear, brake torque gradually decreases, and the volume of fluid necessary to fully retract the linings increases. This brake provides a built-in lining wear indicator. As the linings wear, the distance of dimension A decreases. The decrease of dimension A is directly related to the amount of lining wear. Lining replacement is necessary when the distance of dimension A reaches 0. This brake is designed for use with a rotor disc thickness of 1/2 inch and a disc diameter of 9 inches to unlimited. Meeting the needs of our customers is the #1 goal at MICO. If you need additional information, please contact us by internet, fax, or phone. MICO is ready to serve you.